So there's another method of finding volumes of revolution, and that is the cylindrical shell method. Now that's usually used when you've got a region, let's say this is the region, and you're rotating it around, let's say the y-axis in this case, and I'm going to draw a vertical rectangle. You'll note that the rectangle I drew is parallel to the axis of rotation, and when you do that and rotate that rectangle, you get what this object called a cylindrical shell. It's not a washer. I know it looks like a washer because a washer has the hole that's, it's basically a disc with a hole in the middle, and the disc method is always going to occur when you're rotating a rectangle that's perpendicular to the axis of rotation. And the idea is that you draw one rectangle, you rotate it, you got another rectangle here, you rotate that. You're going to be making these concurrent cylindrical shells, which you can see here. And if you can just get the volume or a expression for the volume of each of those, or the arbitrary shell, then you're just going to add them all up as x goes from, I guess in this case, A to B. Right? So each rectangle produces a shell. Now the general formula for a shell, for the volume of a shell, is if you look up here, we've got the shell. This is the radius. Right? That's the radius of the cylindrical shell, and that's in this picture going to be this. Let's just say it's the red rectangle there. There's your radius. The height is f of x. And the thickness here is dx. And that's just the width of your rectangle. So if you sort of snip along the length, the height of that, in order to get an expression for the volume, if you snip along the height of that and unravel, you get this rectangular prism here, this really thin rectangular prism. And we can see that the height is just, of course, f of x still. That was poorly written. The height is just f of x. The width is just dx in this case, and then the length is the circumference, because when you snip and unravel, it's going to give you the this length here is just the circumference of that circle at the top. So that's 2 times pi times x, the formula for the circumference. And so therefore the volume in this case would just be length times width times height, or length times height times width. And so there's like a general expression for the volume of a shell, and then we'll end up just summing them up. We'll sum them up as x goes from A to B. All right, so we'll look at an example in the next slide. So here we have a region enclosed by the x-axis and the parabola y equals 4x minus x squared. So first we need to graph that. I'm going to factor out an x to get x times 4 minus x. So 0, 0, and 4, 0 are your x-intercepts. And there's your region. So if you, so we're rotating this around the y-axis. Now here's why you probably can't use a disk method or a washer method. So let's just say you're like, all right, I'm going to draw my rectangle perpendicular to the axis of rotation. The problem with that now is that you'll get a washer, but because you drew a vertical or a horizontal rectangle, you're going to have to integrate with respect to y, which means you're going to have to name all the points on this curve in terms of y. But that's a problem because y equals 4x minus x squared is not easily solvable in for x in terms of y. I mean, you could make a piecewise function or something, but that's just not practical. So we're kind of forced by the nature of the asymmetry of this equation to draw a vertical rectangle. So we're going to integrate with respect to x. So when you do that, you'll get your cylindrical shell. So the height of the shell, you can see, is just f of x. It's this length here. So that's and so I'll call that h. And that's going to be the y-coordinate of this point, but this is the curve 4x minus x squared, so it's x comma 4x minus x squared. All right, and then the radius here, the radius is this distance here, but that's just that x-coordinate there, which is just x. So r equals x. And then the actual thickness here is clearly dx because we drew a vertical rectangle. And so our volume is going to be 2 pi x times the height times dx. And so our total volume is going to be the integral, so we're adding these rectangles up as x goes from 0 to 4, 2 pi x times 4x minus x squared times dx. So there's one example of the cylindrical shell method. Again, many times you can use the disc method or the shell method or a washer in whatever the situation may be, but this particular example is one in which you really kind of are forced to use the shell method because you have to draw a vertical rectangle and the axis of rotation is parallel to that. So you make it makes a shell. Let's look at that same region but rotate it around a different axis. I'm going to change this slightly. This says to rotate it around the line y equals -1. I'm going to rotate it around x equals -1. And so when we do that, we've got this region and x equals -1 is right here. So I'm going to draw a vertical rectangle. And when you rotate that, you still get a cylindrical shell. Now the height of the shell is still f of x, right? This is the point x comma 4x minus x squared. The height is just 4x minus x squared. And the radius this time is a little different. So the radius, I'm going to just indicate like this. The radius goes from here all the way to the axis of rotation. So this is my radius. And so we need a description for this horizontal length. But the x-coordinate of this point here is x, and the x-coordinate of this point here, or any point on this line, is -1. So if you do x minus -1, that's how you would get that distance. But x minus -1 is x plus 1. So you get x plus 1. And then this thickness here is a dx because we drew a vertical rectangle. So therefore my volume is 2 pi x times, sorry, 2 pi x plus 1, it's 2 pi r, times the height 4x minus x squared times dx, and so the total volume is equal to the integral, still from 0 to 4. Focus on the rectangles you're going to be drawing. Those go from 0 to all the way, they start at 0 and go all the way to 4. So from 0 to 4 of this expression.